talking about typically an economy with different sectors of production, okay? And so our goal is typically to figure out how much external demand we could meet, or given some external demand, how much our total production needs to be. So our total production is equal to our internal demand plus our external demand. So internal demand is simply just that what it takes to make the products. This is kind of the idea that if I want to give away a dozen cookies, that would be external demand, that while I'm producing that dozen, maybe I eat some cookies. So maybe in order to make a dozen cookies to go somewhere else, I actually am going to eat 2 cookies myself. So I need 12 cookies for external demand. I'm going to eat 2 cookies while I'm making cookies. So my actual total production will be 14 cookies. Now it's not that straightforward because we have these different sectors that are interrelated to each other. So our total production is a vector x with the multiple sectors. Here we can see that we have an x of 2 sectors, x1 and x2. And so A times x gives us that internal production. And it's because in order to make a product, it actually takes many different inputs. So when we start with our x is equal to ax plus d, our classic starting point for an input-output problem, we want to recognize that typically we want to solve for x. So this is going to be x minus ax is equal to d. And in order to solve for x, we want to factor out that x. So we want to realize, though, that it's a times x, so I need the x to be the second term. So when I factor out x, it's going to come after my bracket. So if I pull out an x from itself, I'm left with the identity matrix. And if I pull out the x from ax, I'm left with that minus a. I don't actually want I minus ax equals d. I want to know what x equals. So I can take the inverse of the I minus a matrix and multiply it by itself. And then do the same thing on the other side. And so this leads me to the x is equal to I minus a inverse times d. So we want to recognize that the A matrix is what we call the technology matrix, and it's going to always tell us, each entry is telling us the amount of sector I required to make one unit of sector J, and that the I minus A matrix is going to be the change in production required. So the A matrix, the technology matrix, is just how much does it take to make a unit, but I minus A is the change in production in order to meet a 1 unit increase to external demand. So what do I have to do to my production to meet external demand? Okay. So if we're looking at the technology matrix of 0.5, 0.4, 0, and 0.3, where sector 1 is paper and sector 2 is oil, what this is telling us, right, we want to make sure we understand that if sector 1 is paper, we've got our paper, and then we have oil. Our entry of 1, 1, so that's 0.5 there. Our sectors go in the same order, paper, oil, paper, oil. So this 0.5, A11, is telling us that it takes 0.5 units of paper to produce 1 unit of paper. We kind of think about it as in the side, out the top. We can also think about the fact that it's always going to be the amount of I to make 1 unit of J, where I is going to be whatever our first element is, and J is going to be whatever our second element is of those subscripts. So A12, which is our 0.4 value, that is telling us that it takes 0.4 units of paper, because again, we're going in that side, to make 1 unit of oil. And A22, it didn't actually ask us for that, but A22 is that it takes 0.3 units of oil to make 1 unit of oil. Because again, we're going in that side and out the top, and this is 0.3. If we have I minus A inverse, well then this is telling us how much of the product is going to be needed in terms of production to satisfy external demand. So again, we're still dealing with the sectors of paper and oil. So that sector 2, that number 2 there in entry 1.1, that's the amount of paper it takes not to produce a unit of paper, but to send a unit of paper externally. Entry 1.2, the 1.14, that's the fact that it takes 1.14 units of paper in order to send 1 unit of oil externally. So in a question, they might give us the technology matrix A, but typically they like to give us an input-output table. And it's a table because it's going to talk about total output. And we want to realize the fact that the technology matrix A, it's not about total output. It's about the requirement for a single dollar or unit. So we'd always want to divide by whatever our total is. So we're going to take that 40,000 and we're going to end up dividing it by the 400,000. And that would give us a value there of 0.1. If I take the 4,000 and I divide by that total of 400,000, it's going to give me my total of 0.01. For oil, we are using $50,000 of wheat to make $200,000 of oil. So if I divide that by that $200,000, it gives me this value of 0.25, meaning that it's taking 25 cents of wheat to make $1 of oil. 10,000 divided by that 200,000 is going to give me my 0.05. And so what we actually found there are the entries into the technology matrix. So no matter what question they ask us, we always need to find the technology matrix. So A is going to equal 0.1, 0.25, 0.01, or 0.05. And in this question, it says a company must meet the external demand of $300,000 of wheat and $100,000 of oil. What is their total production? So they're telling us what the demand is. And remember, we did this wheat and then oil, right? That's the order it was done in our chart, and we did it in the technology matrix. So wheat is 300,000 and oil is 100,000. And they want to know what is the total production. So total production is our X value. So this is telling us that we want to use the fact that X is equal to I minus A inverse times D. So if we have that A matrix, we want to first find our I minus A. So we are taking the identity matrix and we are subtracting our A matrix from it. So when we do this subtraction, 1 minus 0.1 is going to give me 0.9 in that first spot. 0 minus 0.25 is going to give me negative 0.25. 0 minus 0.1, negative 0.01. And 1 minus 0.05, 0.95. From there, I want to find the inverse, right? I minus A inverse. Because this is a 2 by 2 matrix, we can use our 2 by 2 shortcut, right? That 2 by 2 shortcut tells us that we're going to go 1 over, right? If I have the matrix A, B, C, D to the negative 1, that the inverse is A, D minus B, C times I switch D and A and I put a negative on B and C. So we're going to do that here. So 1 over A times D is 0.9 times 0.95 minus B times C, so negative 0.25 times negative 0.01. And then we switch our A and our D, so 0.95 comes up, 0.9 goes down, and we're going to multiply our B and our C by a negative, meaning that they're now positive. So this gives me 1 over 0.8525. The rest of my matrix is currently the same. And I want to actually divide that number into my matrix. 0.95 divided by my 0.8525 is going to end up giving me 1.142. 0.25 divided by my 0.8525 is going to give me 0.293. On the bottom, I'm going to have 0.012 and 1.056. You can get some really funky decimals going on here. And so typically we keep 3 decimals in these problems. So now that I have the I minus A inverse, I know that my production is just that I minus A inverse times my demand. So in order to actually find production, we're taking our I minus A inverse and multiplying it by our demand. So we're taking this matrix that we have, the 1.142, 0.293, 0.012, 1.056, and we're multiplying it by that 300,000 and 100,000. So if we multiply this out, right, it's going to be that first row, times that column. And so my X matrix here, or my X values, are going to be 1.142. And you don't have to write this out if you're a solid matrix multiplier. And in my second one, excuse me, so sorry. We're taking that value of 0.012, multiplying it by 300,000, and then the 1.056 times 100,000. Okay. And so this is going to end up giving us the values of $363,500 and $109,200. If you kept more decimals, you might have a slightly different number. And so this is saying that to satisfy our external demand, we must produce $363,500 of wheat and $109,200 of oil. So in this problem, they gave us demand, they wanted production, so we knew we needed to use X equals I minus A inverse times D. On the next question though, they say they currently have the capacity of producing 1 million units of wheat and 2 million units of oil, and it wants to know the maximum level of external demand that they could meet. So we want to recognize that it's really telling us what our production could be, that it could be 1 million of wheat and 2 million of X. And I'm going to do this problem in millions. I just want to recognize that whatever units we put into the problem are the units that we get out. So that first problem we put dollars in, so we got dollars out. Here I'm going to use millions of units, and that's what I'm going to end up getting out in my answer. And I want to know what that level of demand is. So recognize that if I have X equals AX plus D, I want to solve for D So x minus ax equals d. So I could use this one. I could also go one further just to simplify and use the I minus a times x equals d since we already have the I minus a matrix, okay? So this is telling us then that our demand, maximum that we could meet for external demand, is going to be I minus a times x. That I minus a matrix was 0.9, negative 0.25, negative 0.01, and 0.95 times that x value, and our x value was 1 million units and 2 million units. So if we multiply those out, we end up with 0.4 and 1.89. But remember, these are in millions of units. So this is telling us that we are capable of meeting external demand of 0.4 million units of wheat and 1.89 million units of oil. So typically they're going to ask us a few different input-output things. Typically one of them is going to be they give us demand, they ask for production. They give us production, they ask us for demand, or they could ask us for the change. So question 3 here says, if they expect next month's external demand to increase by $1,000 in wheat, but demand for oil will fall by 50,000, what's the change in the production that they can expect? And again, for input-output, whatever units we put in are the units we get out. So if this is giving me the change in demand as being, hey, I'm up $100,000 for wheat, but I'm down 50,000 for oil, then my change in production is just going to be that I minus A inverse times the change in demand. So my change in production, I already know my I minus A inverse, right? 1.114, 0.293, 0.012, and 1.056. And my change in demand is I'm up $100,000 for wheat and I'm down 50,000 for oil. And so if I multiply this out, I end up with 96.75 for wheat and negative 51.6 for oil. So what this is telling us is that production will increase by $96,750 for wheat and decrease. So this is not our total production, this is our change in production. So it's going to decrease or it's going to fall by that $51,600. And I could have put into this instead of 100 and negative 50, 100,000 and negative 50,000, but you can just do whatever makes your life happier.